In this video, let's take a look at exponential transformations. So we're going to state the transformations that occurred between the parent function y equals 2 to the x and the following. Alright, so example 1, we have a 4 out front that makes it have a vertical stretch or expansion by a factor of 4. Then the minus 2 is in your exponent, so that's kind of like our grouping symbol for exponential. So the minus 2 makes it shift to the right 2. And then the 3.99 just makes it a growth function, but it's not part of our transformations. Let's look at example 2. The 1/2 out front makes it have a vertical shrink or compression by a factor of 1/2. Let me write all that down. Vertical shrink. Let me spell that a little better. Shrink by a factor of 1/2. The 0.07 makes it decay, but again, that's not a transformation. That's just growth versus decay, which we looked at before. And then the plus 5 would make it shift up 5 because it's not in a grouping symbol. It's just out back by itself. In example 3, we have 4,000 out front. That makes it vertically stretch or expand. So I'm going to say vertical expansion by a factor of 4,000. So a big expansion. And then the positive 8 in our exponent makes it go to the left. 8. Example 4, we have a couple things going on. So we have a negative in the front. That makes it reflect over the x-axis. The minus 31 in our exponent makes it go to the right 31. And then the positive 20 out back here makes it go up 20. Example 5, we have 0.75 for our a value, so that makes it vertically shrink or compress. So I'm going to say vertical compression by a factor of 0.75. Then the minus 189 is not in a grouping symbol, so that makes it go down 189. In our last example, we have a really large vertical expansion or stretch. They mean the same thing. So vertical stretch by a factor of 45,000. And then the 8,000 just makes it go up. 8,000.